Hello, here today my topic of the presentation is the unit, the brain MRI image segmentation. Actually, our objective of the image segmentation for the detecting the brain tumor or the brain cancer. Actually, the brain tumor also called is the brain cancer. But now the recent classification of the genomic subtype of our image. Actually, our image, according to the WHO, it is the grade 2 or stage 2 cancer of the brain tumor and the stage 3. And here for this study, we are taking that 110 patient data uh, of the MRI images. Yes, so here the first thing of my coding implementation is we need some dependency for this. So the dependencies type of the NumPy, Matplot, Pandas, and CV2 for the computer visualization of the image and the segmentation and the keras, and we are doing these things in the online Google Colab platform. Okay, so here in this our input images are showing, and here this all are the my dependency. Okay, so after that we will actually create the data frame through the TensorFlow of the pre-process the data. And okay, so this process is ongoing on the diagnosis. After the pre-processing of my data, will create the marks for the image in our data set, and after that we will see that how many data we have. Actually, this is also the diagnosing of my images, brain MRI images. Uh, so it will create first the image path. After that, it will create the marks path and diagnose. So after the diagnosis, here we are seeing the total number of image to our the number of the no tumor image or the our healthy people images is the 2556, and with the image of the affected of the MRI image, the number of image is 1373. So now we'll visualization the before that I'm saying that creating the marks and the diagnosis the in the MRI image have any kind of abnormality or not. So now how we will visualize these things. So in the next step, we'll going to yes. So in these things, actually there is the abnormality case for this image is showing like this portion or this area. Now this area is we can grade it as the stage 3 according to the WHO, World Health Organization, and this is a really very small area. They graded as the stage 1, sorry, stage 2 and stage 3. So that this is some other example of the segmentation of the brain MRI image with the affected. So after that, where do you go? Now we are just before that we just take some random image of the affected, but now we will see that split our data into the three part. One is the our training, another is our validation, and last thing is our testing. So for the training, our total number of data is the 2838, and for the validation is 501, and for the testing we have the number of the image is the 590. So Going to the next to the, so we split our data into three portions. Now what we're going to do next, this is my unit model. So we chose the unit model for our image segmentation. So first we will data generate and the data augmentation and adjust of this data. So here is the, actually we do this for the smoothness of the data. Actually this is the formation of the unit model. Actually how this model is taking, and actually down now this is the for left side and right side, it is taking the four segmentation. So this unit is basically is the, actually the C convolutional neural network architecture, and in the biomedical engineering the first use of the unit or discover of the unit is 2015 from a German university, and this is the fully convolutional neural network, and this is actually we are saying it's unit because of its shape. Actually its shape as the unit. So after that you can see in the left side there is the four block for the encoder, and in the right side there is a four block for the decoder in the output. So in the input and output, and this the most the important feature of this is the it's extract the multiple convolutional layer through, and it's decoded through the transpose convolutional layer. So going to the next, this is actually our the training data set of this. We will do our training for the 50 epoch normally, and our message is the only the 32, and the learning rate we want e to the power -4. So after that, what we are saying that our number of epoch is already start to for the training, and after that, yes, the number of epoch is uh, increasing after the 4. What we are seeing that the loss of our function is that 0.83. First our start of the loss was the 1.2. So after the 21 epoch, we are seeing that our loss is minimized into the 0.27. So our program is running, it is also using the GPU. So after the 21, it's the 2.7, 0.27, sorry, and okay. So after 34 epoch, it is the 0.19. It's quite good. So now after the training, so this is actually our loss calculation. You can see the through the graph that how many the first the loss was the something like 1.4. After the 10 epoch is less than 0.2, 0.1 something. And this is the another actually our for our training through the IOU intersection of the union among the images of the, is there is any area is affected, so that will checking through the intersection of the union. And another coefficient we choose for our this study is the dice coefficient. So dice coefficient is the similarity coefficient is the spatial of the overlap index and the responsibility for the validation matrix. So after that, what we'll go the test. So with the 590 image file for the validation and the testing, here our dice coefficient is saying that it's the accuracy is the 89% something. So here this is our original image. From this we don't have any overlap or in the original marks, and in the prediction there's nothing. So in this, in the original image, we are seeing something is actually abnormality in this portion. So here this is in the original marks. So this portion they did, after that the prediction is saying that it has the cancer. So after that, what we are going to do, that prediction of the every image, the true, false, or the we can say that correct or incorrect, that prediction, and in the finally which test the accuracy, it is the 94. That's it. Thank you.